Hello and welcome, fellow coders. Thanks for joining me today for one of the more complex topics in Go's programming language. I'm talking about pointers. If you find them a bit confusing or don't understand how they work, don't worry. I'm going to explain them to you in a very easy and understandable form. So let's hop into the IDE and let me start by giving you an example. Let's define two integer variables a and b, where a has the value of 42 and b has the value of a, so 42 as well. Printing out both values shows nothing unexpected. The value 42 gets printed out twice. One could assume that both variables have the same memory address, since here b gets assigned with a, but changing the value of a and printing both out shows us that the value of b is not connected to a whatsoever. That is because when the value of a gets assigned to the variable b, Go actually creates a copy and stores it into a different memory address. So again, a and b are completely independent variables with different addresses in memory. Okay, now let's get rid of these lines right here and finally get into pointers. Let's start by answering the question, what are pointers? Pointers are a data type that do not store values, but rather store memory addresses. To show you that, we will let b point to the same memory address of a. To do so, we first need to turn b into a pointer by prefixing the type with an asterisk. b is now a type of integer pointer. You can already see that my IDE is not happy, because I cannot use a of type int as the type pointer of int. To fix that, we can make use of the address of operator. This will let b point to the same address of a. So this line can now be read as b is of type pointer to an integer and is pointing to the value of a. Now let's see what the address of operator does. It prints out the representation of the memory address of b, which has this hexadecimal form right here. As explained earlier, b is not actually holding the value of a, which would be 42, but instead is holding the memory address of the data of a, which is 0xCOO and so on. Now to see if the memory address is actually the same, we can use the address of operator in front of a. And as you can see, when running the code, both memory addresses are the same, so b is indeed holding the same memory address that a has. Alrighty, we have seen that we can use the address of operator to retrieve the address of a variable and store it into a pointer. But we can also go the other way around and use a different operator to retrieve the actual value of a pointer. And that operator is called dereferencing operator. Notice that, even though we also use an asterisk as the dereferencing operator, it has a different meaning than the asterisk in front of the integer type. This asterisk is declaring a pointer to a data type, while this asterisk is dereferencing the pointer b. If you run this, we can see that the address of operator in front of a pulls out the memory address of the value 42 stored in a, and the dereferencing operator pulls out the actual value referenced by the memory stored in the pointer b. This is how you can use pointers, as well as the address of and the dereferencing operators. But what is the whole point behind pointers? Pun intended. If we go ahead and change the value of a like we did before, running the code now shows us something very interesting. The dereferenced value of the pointer b also has the same value as a. This shows us that a and b are now closely tied together. We can even go ahead and change the value of the dereferenced pointer, and as you can see, this will also change the value of a. Again, a and b are now closely tied together, because they are both pointing to the same memory address. Now, if you're familiar with the concept of pointers from other languages like C or C++, you might expect pointer arithmetic. Well, Go does not have that. Even though pointer arithmetic leads to super fast running code, since you directly operate on the memory addresses, typically this also leads to very complex code. And since Go was designed with simplicity as one of its major core principles, the developers decided to leave that feature out. Okay, now the last thing I want to show you is that pointers, as with every type in Go, also have initialization values or zero values. If you remember from one of my first videos about Golang's basic types, the zero value of, for instance, an integer type is 0. But what about pointers? Since they are pointing to the memory address of a value, if they do not have an address to point to, their zero value must be non-existent, right? Well, not quite. It turns out to be nil. In Go, nil is the zero value for all maps, interfaces, slices, channels, function types, and as you can see, for pointers. Nil basically means that this variable is uninitialized. So keep this in mind if you want to check the variable. Instead of checking for 0, you have to check for the pointer data type. So you have to check if a is nil. And that is it for pointers. I hope you have seen that they are not that complex as you might have thought. I hope you enjoyed watching this one. If you did, you know what to do. And until next time, keep on coding!